Welcome to PROSTEP's digital thread platform with OpenCLM for aerospace and defense. My name is Brian Scouten, Director of Technical Presales for PROSTEP Inc. And in this video, we'll be talking about OpenCLM, the architecture, and different use cases that you can accomplish with this platform and using traceability. PROSTEP's digital thread platform is designed to integrate, federate, and migrate data across your product lifecycle management systems and different repositories that store data there. So that could be from requirements to system architecture and different types of designs, mechanical, software, electrical, analysis and validation, and production and manufacturing and quality management and sustainment. So bringing together these commercial off-the-shelf connectors for the different systems in order to kind of help that process, the data flow, creating a digital thread, moving forward the digital twin across the product lifecycle. The PROSTEP Digital Thread Platform has a foundation of your existing systems and the repositories that you use today in order to store and release that authoritative source of truth data from the different domains and tools that you use. So we have these connectors that then connect to those tools in order to accomplish integration, data exchange, traceability, and migration. Connectors, then we have sets of tools that we can use in order to provide that. Some of those tools are like monitoring tools, orchestration tools like BPMN workflow, mapping tools, and transformation tools for things like CAD processing, managed file transfer and secure file transfer, and other types of processing tools for data. Today's video, we're going to focus specifically on traceability that uses orchestration in the templates within OpenCLM and processing data there. So you're going to see, using linked data, the ability in order to trace data from different domains within a template that then showcases a process that you might have different systems involved with that you need to provide configuration lifecycle management for, hence OpenCLM. So the purpose of configuration lifecycle management and OpenCLM is first management, that is the project management or program management, and the ability to take a template that has a process and then apply that with real artifacts within all the different systems that are integrated. Assisting in development, and that could be creating baselines, aggregating maturity states across these different systems, understanding impacts of changes in these cross domains, things like that. Assisting in usage, service, and recycling, or production, right? So identifying the different artifacts from the system, as well as being able to trace back all the way from out in the field to the early engineering concepts and requirements with that digital thread that you've built. And the end goal is to have a holistic configuration lifecycle management system. And this is not something that you want to then migrate all your data to in order to process, but a system that sits on top of your existing sources of truth and then enables you to do this configuration lifecycle management without migration, without ripping and replacing, without changing where people are authoring data or the existing processes today, and then provide that traceability management, configuration management, project and program management, or process management that you need, without augmenting what your processes and are today within your business. Ultimately, a goal is to provide that cross-domain data transparency. So like I said, from sustainment to manufacturing, being able to take the traceability of that data all the way back to the initial system model, back to the requirements, back to the validation test cases, the different changes that happened, and kind of put in context not just what it is, but why it became that, throughout the history of the development and engineering. And this really brings transparency to the product and provides really, all the institutional knowledge that you've accumulated over this, bringing all that together with the traceability that you can then sustain that and carry that on to the next product. So OpenCLM accomplishes this by providing, like I said, a linked data architecture. And that's taking a URI within OpenCLM that's stored there that then points to different artifacts within different systems. So that could be a requirements module or a requirement, or it could be a UML model, or maybe just a UML block. Could be a whole assembly, hardware, or it could be a component, or it could be even just a data set within your PLM. Or a software artifact, or an issue, or a material, or a change, or things like that, a release process. Could be any of these different types of business objects within these different systems. And those are then all linked back to OpenCLM so that you can then pull data from there and have traceability from the configuration and the process you have within OpenCLM into these different systems to kind of provide that digital thread and overall configuration lifecycle management system. So architecturally, it looks a little bit like this. It's a modern system with microservices and a MongoDB that enables some flexibility with the data types that you're storing. Has modern IDP integration so that you can use that with the connectors and the backend systems as well. And then can provide connectivity through a standard OSLC consumer that it has to OSLC provided systems like ALM systems, requirement systems, or through the existing OpenPDM connectors. And we've got quite a few of those connectors across a lot of different engineering and manufacturing systems as well. It has a modern Spring framework as well as GraphQL that can be utilized for reporting. So you can create very comprehensive reports from the data that's contained within OpenCLM and kind of expose that to the rest of your enterprise as well. So let's do some demonstration showcasing some functionality within OpenCLM. You see on the bottom, there's some integrated systems, and then we have a process within OpenCLM that we've set up of change, and that starts with identifying potential changes, doing an alternative solution review, and then showcasing within there a trade study of the different alternate solutions, as well as some impact analysis. So let's go ahead and jump into OpenCLM and show you some of the functionality in order to accomplish these tasks. So we start within OpenCLM, and you see there that there's a blue block of the development of alternative solutions. That actually also exists on the tree view on the left, and is then broken down with different relationships to kind of show the graph of dependencies from what the template is so that you can see the development of the alternative solutions to then the solutions themselves that are configuration items and artifacts within other systems. Those could be requirements, those could be designs, and other things. So we filtered the relationships so that we're just getting the data that we want to see here. And we see the three different proposed solutions as the alternates. So you see that one of them is a track drive, like a tank might have. One of them is all-terrain wheels, and another one is a digital differential block. So all these are solutions to the issue that there is problems with the wheels slipping on the Mars rover, right? Those then depend on the powertrain as well as chassis components, and you can see that the track drive has dependency on both of those, where the wheels just have a dependency on the powertrain and not the chassis itself. And the digital differential block is purely then a software update and has actually no mechanical dependencies, so just a dependency on that Raspberry Pi that it was connected to. You can then drill down into the different components of that. So you can see then the dependencies there, the product structure items there, as well as the software artifacts that might be within the drive electronics, as well as then some of the requirements and system model components that might be related to these overall as well. In this demonstration, we'll showcase from your alternative solution development that you had last time, kind of break down the different components and then artifacts that are linked within those other systems like Windchill or Teamwork Cloud from Cameo Systems Modeler back into the configuration lifecycle management in OpenCLM. So we'll start back with the development of those alternative solutions. You see they've got the 3 different published solutions. On the right-hand side, we've got the proposed solution for a digital differential block. And so that's a software solution that then has a dependency on the Raspberry Pi ECU, as well as the ARM there. So then we can select the digital differential block, and we then go to see the details on it. You see that the central control and the logic behind that is actually something that is a diagram within Teamwork Cloud, so that you've referenced directly there, and it's pulling in attributes from Teamwork Cloud as well. You can then also go to the Raspberry Pi ECU that this is then based on, and then take a look at the hardware then that's within Raspberry Pi. And you see that that is sourced within Windchill. So looking at details there, we're pulling in attributes from Windchill. And you can also click through in order to go into the Windchill interface itself. So you can see the Raspberry Pi model, but then look at and other details that you might want to see within there. Some of those attributes are federated in, so you can get access to files that are within there, be able to process attributes for other type of validation and impact analysis, and other reasons there as well. So any one of these different configuration items and blocks within OpenCLM could then have those external artifacts that you're relating to, so that you can then process all that data together. And all this really culminates into a highly valuable proposition of being able to easily integrate data from multiple domains, not having to rip and replace these systems or do migration. So you can do things like ensuring compliance, do your digital thread and product traceability. You can use whatever tools you want to use because what we're end up doing is integrating to those and not forcing adoption of a specific tool, and really kind of provide that configuration lifecycle management across your whole enterprise with OpenCLM. So that wraps up our presentation for today. Please remember that PROSTEP's here to help. So if you've got a question, send an email to infocenter@prostep.com. We've got hundreds of consultants that can help. We've been doing this for a long time. And we've got standard practices and software that can assist you in building that digital thread, digital twin, and having a more integrated enterprise. And thanks again.